the chapter laws of motion. We have discussed some numericals based on the laws of motion. Last class we have discussed about the weighing machine. We have discussed about the problems related with the pulley, and also we have discussed about the Newton's second law of motion is a real law of motion that we have discussed. Today I will be discussing a new topic which is called as the law of conservation of momentum. This you have already got in the lower classes that the conservation, that is a momentum before the collision. That means before the collision. What do you mean by the collision? Like suppose if you consider two objects, if it collides with each other, this is called as a collision. So the momentum, that is the amount of motion contained before the collision, before this amount of momentum, this and this, if I consider total momentum of this, after the collision, both the momentum before and after, both will remain as a constant. Okay, this is called as a law of conservation of momentum. As for example, we have some practical applications like when we fire a gun, we used to, the body used to move back. Okay, we used to get a feedback from the gun. Okay, so that we call as the recoil of the gun. So as you can see here,
the gun and the bullet are in one system. Initially, the gun and the bullet are at rest, which means the momentum of the system is zero. As soon as the bullet is fired, it moves forward with a very high velocity. Thus, there is a force exerted by the gun on the bullet in the forward direction.
So as you have seen that when we fire the bullet, so the bullet moves very fast in the forward direction. So to conserve the momentum, this rifle, it used to move backwards. This is because of the law of conservation of momentum, because initially the total momentum is equals to zero, because both the gun and the bullet was at rest. But after firing what happens, since the bullet moves forward at a very high speed, so to conserve the momentum, so this gun also moves backward. So we have to prove that how does the law of conservation is to be done. So we'll be doing it mathematically. Let us see how to do it mathematically. Okay, so for the law of conservation of momentum, we have this diagram. The object A, object B having a mass m1 and m2. The first object is moving with the initial velocity u1 and the second velocity is moving with u2. Here the condition is given that the u1 is greater than u2. That means the first object is moving at a higher speed than the second object. So then only this first object will go and collide with the second object, because it is moving at the same speed and they are moving along the same direction, as you can see. Then this is before collision. When the objects collides, okay, this is the during the collision condition. So this object will exert a force on B, and similarly B also will exert a force on A. Okay, so this is according to the Newton's third law. Therefore I can write force applied on one, that means force applied on A, or you can write this one as force applied on A by B, force applied on B by A. Okay, A by B, this is this one, B by A. Okay, B by A is this one, A by B is this one. Similarly, we have after the collision, both the objects will move after the collision. So this will be having a velocity of v1, the other one will be having a velocity of v2. Okay, similarly, like suppose we are moving a truck, and a truck goes and collides with a car. So the truck moving with a higher speed, if the car is moving at a slower speed, if they collides, okay, after the collision what will happen? The car will move with a higher speed, and the truck will, the velocity of the truck will not change. There will be a slight minute change in the velocity of the object that will be happening in the after collision. Now suppose if I consider before collision, what will be its momentum? Momentum before collision. Before collision. Okay, momentum before collision. The formula for the collision, that is a momentum, is mass into velocity. You see, before collision, first object will be having a mass m1, velocity is u1. So first object momentum is m1 u1. Second object will be plus m2 u2. This is the momentum of the second object. Similarly, momentum after collision will be equals to m2 u2 So here it will be m1 v1, that is of this one, moving with v1, mass is m1 plus m2 v2. So this is the momentum before collision and momentum after the collision. Now suppose if I consider what is the change in momentum of the first object before and after. So if I write change in momentum of A will be equal to what we can write, change in momentum of A, it will be the final minus of the initial, that will be m1 v1 minus of m1 u1. This will be the change in momentum. Clear? If I write the change in momentum of B, change in momentum of B, what we can write, this will be m2 v2 minus of m2 u2. This is the change in momentum. Okay, so you can see there, this is the change in momentum. B and E I have written here. This is for A and this is for B. This is the change in momentum. Now suppose if I consider according to the Newton's third law. Okay, according to Newton's third law, you can write it first. I am writing it. According to the Newton's third law, third law, what we can write, that this, suppose if this is action and if this is reaction, I can write as FAB is equal to minus of FBA, action and reaction force. And we know that FAB is the rate of change of momentum. That means change in momentum I have written. Okay, this is for the object A and this force is on the object B. So this will be the rate of change of momentum of object A, rate of change of momentum of object B. So what I can write in this one, it will be m1 v1 minus of m1 u1 divided by change in time, I will be writing as delta t. Similarly, minus of m2 v2 minus of m2 u2 divided by delta t, change in time. Now suppose if you consider the change in time, what I can do, I can cancel this part. This will be equals to m1 v1 minus of m1 u1. If I put this minus inside, if I multiply it, so it will be m2 v2 minus of m2 u2. Okay, next step what I will be doing, I will just interchanging the position. So this I will be putting this side and this one I will be putting in this side. Let us see what will I get. Sorry, I made a mistake. This should be minus, this should be plus, because this minus will be separated. So now if I interchange the position, so this will be, if I put this side or if you put on that side, the last expression that you will get will be m1 u1 plus m2 u2 will be equals to m1 v1 plus m2 v2. Okay, this is the final expression that we will get. So this expression, as you can see, this is the momentum before collision, this is the momentum after the collision. So we have got it equal. So what does it prove? This is the law of conservation of momentum, that momentum before collision is equal to the momentum after collision. So you have to write it below. This is the law of conservation of momentum, in which momentum before collision is equal to the momentum after collision. Okay, so this is about the law of conservation of momentum. Now let us see some examples related with the law of conservation of momentum, as I have already discussed about the recoil of the gun. So let us see what will be the at how much velocity your gun will be recoiled. So suppose if I consider that, which is recoil of a gun, let us consider what will be its velocity. Suppose let small m and small v are mass and velocity of the bullet. Okay, of the bullet. Similarly, capital M and capital V R for your gun. Okay. Next, suppose before firing, your bullet and the gun both will be at rest. So before firing, if I consider momentum, before firing, momentum will be equals to small m into 0 for the bullet, capital M into 0 will be for the gun. What will be the total momentum then? It will be equals to 0. Similarly, after firing, what will be the velocity, momentum now? M into V, this will be small v, plus capital M into capital V. This will be the momentum after firing. Okay, momentum after firing. So, according to the law of conservation of momentum, okay, according to the law of conservation of momentum, before firing and after firing, momentum should be equal. So, if I write according to law of conservation of momentum, your 0 will be equals to M into V plus capital M into V. We need to find out the value of the recoil velocity. So, we need to find out the value of this. Capital V will be equals to minus M into small v divided by capital letter M. So, this is the value of the recoil velocity. Okay, so this is the topic that you have to write in your copy. So the next class what we'll be doing will be discussing about the next topic, which is about the friction. Okay, so thank you for today. We'll be discussing in the next class. Thank you.